Ellipse by general method. In this video, we will see how to draw an ellipse by the eccentricity method. We know an ellipse is an oval shape. It has two axes passing through it, that is the major and minor axis. It has fixed points on the axis, called the focus. There is a perpendicular line to the axis, which is called the directrix. Also, it has a point on the curve, at the axis, which we will name as V. Each point on a curve is at a specific distance. This distance is given by eccentricity. This intersection point we will name as C. These are the important points for drawing the ellipse. Here are the instructions for drawing an ellipse. Draw an ellipse, having the distance of focus from the directrix 50 mm and eccentricity 2/3. Also, draw the normal and tangent to the ellipse 75 mm from its directrix. Here, we can see this distance of focus from the directrix is given as 50 mm, which is this distance. And the eccentricity, which we denote by E, is given as 2/3. Here, we have to remember that if the value of this eccentricity is more than 1, then we get a hyperbola. If the value is less than 1, we get an ellipse. And if the value is equal to 1, we get a parabola. In this case, it is less than 1, so it is an ellipse. Eccentricity is the ratio of the distance of a point on an ellipse from the focus to the distance of the same point from the directrix. This means that if we take any point on this ellipse, the ratio of the distance of this point from the focus to the distance of this point from directrix will be equal to 2/3. The eccentricity is given as 2/3. This 2 plus 3 will be equal to 5, which means if we divide this distance 50 mm into 5 equal parts, then the length of VF will be 2 parts, and VC will be 3 parts. That means, this V point is 20 mm from the focus point, or it is 30 mm from the directrix. Since we understood this, let's start drawing. First, we have to draw a directrix, which is just a vertical line, which can be of any length, and mark a point on this directrix, and we will name it C. After this, we have to draw a perpendicular line to this directrix, which will be our axis for the ellipse. To draw this axis, we will take a protector and mark 90 degrees. And by taking this point as a reference, we will draw a line from point C. Next, mark a point on the axis at 50 mm away from the directrix, and name this point as F, and it will be the focus of an ellipse. After this, we need to mark point V on the axis. This point will be 30 mm away from C and 20 mm away from F. So take the ruler and mark a point 30 mm away from point C. Next, we need to draw a vertical line from this point V. To draw a vertical line, we will use a roller scale and take this line as a reference. Move the roller scale to point V and draw a vertical line of some length. After this, take a compass and take this VF distance. And by using this distance, cut an arc on this vertical line passing through V. And mark this intersection point as E. Next, draw a line passing from points C and E, and extend this line. After this, we need to take the protector and keep it at this point F. And mark a point at 45 degrees. By taking this point as a reference, draw a line from point F. This intersection point will give us the other point of the ellipse on the major axis. Draw a vertical line from this point. This is the endpoint of the ellipse. After this, mark some points on an axis. The distance between these points can be anything. They can be at equal or unequal lengths. For marking these points, we will take a scale and mark the points at a 10 mm distance till this vertical line. Do the naming for these points. 1, 2, 3, and so on, till 12. After getting these points, we will draw a vertical line at each point, such that they touch this inclined line. These lines are drawn using a drafter or a roller scale. Take this line as a reference, and draw the vertical lines at all the points. Mark these intersection points as 1 dash, 2 dash, 3 dash, and so on, till 12 dash. After this, take a compass, take this length between 1 to 1 dash, and using F as the center, cut arcs on both the sides of this vertical line, 1 to 1 dash. Mark this point as P1 dash, and this point as P1. Next, take this length from 2 to 2 dash on a compass, and using F as the center, cut arcs on a vertical line 2 to 2 dash. Mark this point as P2 dash and this point as P2. Similarly, do for all the lengths. Take the length between 3 to 3 dash on a compass, using F as the center, and cut arcs on a line 3 to 3 dash. Mark this point as P3 dash and this point as P3. Next, take the length between 4 to 4 dash on a compass, and cut arcs on a line 4 to 4 dash. Mark this point as P4 dash and this point as P4. Next, take the length between 5 to 5 dash on a compass, and cut arcs on a line 5 to 5 dash. Mark this point as P5 dash and this point as P5. Next, take the length between 6 to 6 dash on a compass, and cut arcs on a line 6 to 6 dash. Mark this point as P6 dash and this point as P6. Next, take the length between 7 to 7 dash on a compass, and cut arcs on a line 7 to 7 dash. Mark this point as P7 dash and this point as P7. Next, take the length between 8 to 8 dash on a compass, and cut arcs on a line 8 to 8 dash. Mark this point as P8 dash and this point as P8. Next, take the length between 9 to 9 dash on a compass, and cut arcs on a line 9 to 9 dash. Mark this point as P9 dash and this point as P9. Next, take the length between 10 to 10 dash, and cut arcs on line 10 to 10 dash. Mark this point as P10 dash and this point as P10. Next, take the length between 11 to 11 dash on a compass, and cut arcs on line 11 to 11 dash. Mark this point as P11 dash and this point as P11. At last, take the length between 12 to 12 dash on a compass, and cut an arc on line 12 to 12 dash. This point will come on the axis. Mark this point as P12. After getting these P points, to get an ellipse, draw a line passing through these points. To draw the curve, we will make use of French curves. Make sure all the points are touching this French curve while drawing the curve. This is the final ellipse, using the eccentricity method. Next, we need to mark a tangent and a normal at a point 75 mm from the directrix. To do so, we need to mark a point on an ellipse, which is 75 mm away from the directrix. By using a roller scale, taking this horizontal line as a reference, we can see that this distance is 75 mm. Make sure that the zero of the roller scale is at the directrix. Now move the roller scale up and see where the 75 mm is coming on the curve. We can see the 75 mm is coming at this point. Mark this point as P. The distance of this point on a curve is 75 mm from the directrix. So, we have to draw a tangent and normal at this point P. To draw a tangent, join this P point with F point with a line. Next, draw a perpendicular line to this PF line at F. To draw a perpendicular line, take a protector, keep at this point. Make sure point F is coinciding at the protector's center, and mark 90 degrees. After this, by taking this point as a reference, draw a line from point F to directrix, and mark this point as T. Now, draw a line passing from points T and P. This line will be our tangent to the curve. Next, draw a perpendicular line to this tangent, which will be normal to the curve. To do so, take the protector, keep it on the tangent, and mark 90 degrees on the protector. Draw a line which is passing from P in this point. This is our normal. I hope you have understood how to draw an ellipse using the eccentricity method.